5.3 says make a neat labeled line sketch of a differential wheel and axle lifting machine. 4 marks. They usually don't ask this question, but I remember drawing it also in one of my sketches to say take note. A differential wheel and axle, it mustn't also scare you. You just draw something like this. You've got this one, the first one, then you reduce it further. You get the second one. You know what, it's simple. It's more of cram it out, then you reduce it further. That, then you're done. That's a differential wheel and axle. See what? Hello again, our most developed student. My name is Confident and welcome to the second session of our revision for engineering science and 2. You guys, if you've been following up, we did question 1 and 2, and this is now where we are looking at the other questions, and we'll see where it takes us. But this is in general the revision for engineering science and 2 that was written on the 1st of July 2022. So as I said, I've done question number 1 and question number 2. So if this is your first time in a way coming in contact with this channel, it means you have not subscribed. So subscribe so that you can become a member of this channel. And also it also very important if you turn on that notification bell so that you can be notified every time I post a new video. It will help you as you prepare for your final exam. Now I keep on saying this channel is designed with you in mind. What am I saying? I looked at you struggling with your maths and science, and I was like, you cannot struggle with maths and science while I'm there. So when I'm bringing this channel, I'm bringing it so that you can prepare. You know, get ready. Don't be a victim of the circumstances. Maybe you don't have access to teachers, extra classes and everything, but through these YouTube channels, you can actually benefit and also have access to different ways of approaching your maths and science. So guys, subscribe. Share it also with your friends and colleagues. Share it now. And also, most importantly, if you become a Prime member, it's very important now whereby you get even to have access to some of the videos which we are not making available to everyone. So it will actually benefit you. So as I said, this we have looked at question 1. We have looked at question 2. It took us a bit long, but now we are looking at question 3. So let's get the ball rolling. So this is the question 3. As I'm doing this is the latest exam, so if you are preparing for your final exams that are coming, use this to see how the examiners are actually thinking. First one is define the term momentum. So that's what they wanted there. You are defining the momentum of an object. Now let me check if we have the formula for that. If I go to our formulas just to see if we've got the formula for the momentum of an object. Okay, I'm not seeing it here. I'm not seeing it, but anyway, so there is no formula, but this is the formula for momentum. How to write the formula? P is equal to mv, where P is the momentum. So what is it? The definition is in this formula. So the momentum is the mass, is the product actually, because there is a dot there. So if they say define the term momentum, you are going saying momentum is the product of mass and velocity of an object. Velocity of an object. So that's the formula for momentum. It is the product of mass. P is equal to mass times velocity. Product means times. So momentum is the product of mass times the velocity of an object. So they give you 1 mark for that. Okay, now 3.2 says an avocado with a mass of avocado with a mass of 150 grams. Be careful of such. 150 grams. When we're looking at mass, the mass is in kilograms, so you need to convert that. So an avocado with a mass of 150 grams hangs from an avocado tree. It then falls freely from 70 meters above the ground level. Calculate the following. So let me read this again with clarity. Let's take this up here. We don't want this to be disturbing us, so let me remove it out of the way. So what are they saying? They are saying an avocado with a mass of 150 grams hangs from an avocado tree. It then falls freely from 70 meters above the ground level. Calculate the following. So just to picture this thing is, you have a tree here. We call it our avocado tree. So this is the ground. So you have a tree that is on the ground side. I mean, this is the ground level. So that's our ground. Again, guys, apologies for the noise that you are going to be getting outside. Unfortunately, there's nothing I can do. I'm recording this, so apologies in advance for the noise. But let me continue. So we have an avocado here that is hanging. So let's say, let me use a different color. This is our avocado that is hanging, and they told us that this avocado is 150 grams. And I'm telling you, don't work with grams, you only know kilograms. So what do? You divide that by 1,000. Okay, so if you do that with the calculator, I think you'll get 0.15 kilograms. So that's the weight, that's the mass of this avocado. So you always know, whenever it's hanging there, there is a force of gravity, that is the weight, the force of gravity that is pulling it down. That's why they say here, it then falls freely from 70 meters above the ground. So if I can then use that information to say the distance from here, that distance is what? It's 70 meters above the ground. I'm using that. So this, not the tree, but the avocado, it's 70 meters. So they're saying it's falling from the ground, and then calculate the following. The potential energy after falling 20 meters from the avocado tree. Now, they are saying, suppose this avocado has fallen 20 meters. Let's say 20 meters, I'm using a different color. Let's say this distance here, from here to here, let's say it's 20 meters. I think that. So if I can continue with that distance like that, it means this avocado is now somewhere here. It's falling down, remember. So that avocado is now somewhere there. So now the question is, we need to calculate the what? The potential energy after falling 20 meters. Now remember, we have a formula for potential energy. We come here to the formulas. There is a formula, there it is, for potential energy. This is EP. It says EP is m.g.h. That is mass times gravity times height. So if I write that formula here to say EP, potential energy for P, is equal to m dot, which is times g dot times height. Now the key thing that they wanted to check you here is the height, h. Now the height, they are saying this is the height above the ground. Okay, so whenever they give you is mass times gravity times height, to know that this is the height above the ground. So now, meaning we need to find what is the height above the ground. So the height above the ground is the distance from here after falling 20 meters to there. So what is that distance? So this distance will be 50 meters, you see. That is now our h. It's no longer 70 meters. Why? Because this avocado is at this point 50 meters above the ground. So now when you're using this formula EP, it will be m, which is the mass, remember to convert it, which is 0.15 times gravity. I think they told us we must use what? 9.8. Remember that in the beginning we did check this. This says acceleration due to gravity. We are using that 9.8. There it is there. Okay, so that's what we're using. So we are going to write there 9.8 times the height there is already in meters, is 50. That's the key thing there they wanted to check you. The rest is just a matter of calculating there. 0.15 times 9.8 0.8 times 50. All right, so the answer there becomes 73.5. Now it's 73.5, but look, it's EP, meaning potential energy, and energy, we measure energy in joules, don't forget that. So that was the part. You get that marks. How many marks? 2 marks. That was 3.2.1. Now 3.2.2. The velocity of the avocado 15 meters above the ground. So they are saying this avocado now, let's remove this part. It is falling, and at this stage it is now 15 meters above the ground. So let me use something different. So suppose this is the distance now. 15 meters above the ground is something like this. So this, let's say it's 15 meters above the ground. So here it's 15 meters. So the velocity of the avocado 15 meters above the ground. So pretend we have our avocado somewhere there now. Remember, it's falling 70 meters up and it is going down, remember. So at this stage we are saying here it is now what? It is 15 meters. So what they want, the velocity of the avocado. So we want to find out the velocity. Now whenever we're dealing with velocity, let's go to the formulas and look at what formulas give us the velocity. There are quite a number. Remember Newton's linear motion. So these are the formulas for the velocity. I mean, that can give you velocity, acceleration, everything. But here I see 2. V is equal to U plus AT. We're not given time, so this we can scratch out. But V squared, U squared, 2AS, that's the formula we need. So I'm going to take that formula and say here, sorry about that. This is the formula I'm going to use to say V squared is equal to U squared plus 2AS, where S is displacement. Now in this case, I can remove that S and write it as V squared is equal to U squared. Remember, it is falling. Plus, now it's falling downwards, so we can consider going down as positive. So it will be 2G for gravity. Acceleration here is the acceleration due to gravity. This one is freely falling, that's your G there. And then S is your height. Are you with me? That is the height that you're going to use. And now we need to be careful now with this height in this case. Or let me remove the height and say, let's call S here as is the displacement along the y-axis. I'll call it SY, meaning the distance it has moved from the top up to 15 meters. So what you need to do is to say, what is the distance that this avocado moved? It moved from here. Let me just do this. This avocado fell from that top there. You see, that's where it fell. Remember, when you're talking about velocity, you should look at where it started. So this is the starting, where U is equal to 0. Where do I get it from? They told us here to say an avocado with a mass hangs from a tree. So if it's hanging, meaning it doesn't have velocity. It has got a velocity of 0. So the initial velocity is 0. Now we want to find the velocity at this stage, V, meaning we need to know that distance. So the simple thing to do is to say 70 minus 15. I think it will give us 55. Because if you say 55 plus 15, 5 plus 5, 10, that's 70. So which means this distance here is 55 meters. So meaning it started from 0 distance and fell up to 55 meters. And we need to know the velocity at that. Now that's what you use here to say V squared, that's what we want to find, is equal to U squared. It falls from rest. We said U is 0. So that is 0 squared. Are you with me? And then plus 2G is 9,8. And then times S is the distance it moved is 55. Don't use 15 because 15 is from the ground. It is not moving from the ground going up, but it is moving from the top going down. So you ask yourself, what distance has it covered? It has covered this distance, which is 55 meters from the start, because 15 meters is left for it to just hit the ground. That's what they said here, to say the velocity of the avocado 15 meters above the ground, meaning it fell 55 meters going downwards. So that's what you needed to be careful on. That's all they wanted here. Then you can finish up to say v squared is equal to, and then you write that. I think it's better to leave it like that, 2,98 times 55. Now to find v, you square root both sides. It's better to find the answer once. So v is equal to square root of that. Don't forget, because for me to remove the square in v, what must I do? I need to square root. Okay guys, so you find the square root of 2 times 9,8 times 55. Am I right? Then you do that, which is equal to 32,832. I want to leave my answer to 3 decimal places, which is 32,833, but I can do that quickly with the calculator. 6 and 3 decimal place, which is what? 32,833. So it's 32,833 what? Meters per second. That's a velocity. You need to know what you're dealing with. So whenever you're giving your answers, give the relevant. Remember, they said formula, substitute units. The answer with the units. All right. The next one is 2.3. Says the kinetic energy of the avocado just before it hits the ground. Just before it hits the ground. Meaning, let's say this avocado is still falling down. Now it has gone down and it is about to hit the ground. Just a little bit on top. Let me just make it just before it hits the ground. I'll make it a little bit. So I didn't touch there. So this is the avocado. So they want you to find the kinetic energy there. But the simplest way you need to know, because they were never specific here, you must know this formula, which says the loss. Remember, when it is falling from the top, it has got EP, that's potential energy. And then the potential energy as it is going down is being converted into kinetic energy. Now at the bottom here, EP is equal to maximum, and then EK is equal to 0. There is no kinetic energy because it is not moving. Why? Remember the formula for kinetic energy, EK. Let's go to the formulas. What's the formula for kinetic energy? EK is half mv squared. That's EK. So I'll come here and say, okay, if EK is equal to half mv squared, at the beginning we said the velocity is 0, so EK is equal to 0. So there is no kinetic energy at the top. But when it reaches the bottom here, it's moving now very fast. Remember, when something is falling from the top going down, the moment it hits the ground, it will be moving at a very high velocity. So here, the potential energy EP, unfortunately it becomes 0. Why? Because potential energy is mgh, and we said where h is the height above the ground, there is no more height here above the ground, so h is becomes 0. So for EP is equal to 0. And then the other thing about kinetic energy, EK, now it is at maximum. So you can see that two things are happening on when you use the conservation of kinetic energy. EP max is equal to EK max. You can use that formula to say EP is equal to EK. Now at the top, we know what is EP. EP, remember we use that formula to say at the top, EP is equal to mgh. Are you with me? So now what is the mass? They say the mass, remember that we use 0.15. And then what is the gravity? 9.8. And what is the height at the beginning? They told you the height is what? 70 meters. Remember, that's what we're dealing with. So you use the actual height here is 70. It will give you the potential energy at the top. So it's 0.15 times 9.8 times 70. It will give us what? It will give us 102.9. Now this is 102.9 what? Joules. That's the potential energy at the top. But I'm saying the potential energy is equal to the kinetic energy. Therefore, you can say, therefore, EK, the answer they want is 102,9 joules. That's the answer here when they say calculate the kinetic energy of the avocado just before it hits the ground. 2 marks. That was the best. But let's say, for argument's sake, you want to go it in another route whereby you are saying, okay, I know the formula EK is half mv squared. Let's say I wanted to stick to the formula, meaning you need to find the velocity here. What is the velocity? Now, to find the velocity here, you go back to that formula. V squared is equal to u squared plus 2as. Then you know it started at 0, so v squared is equal to 0 squared plus 2 times, it's following similar formula we used here, the acceleration due to gravity, but instead of 55, we are now aware it started from 0 up to the ground, which is 70. You see now where the 70 comes in, which is 9,8 times 70, the distance along the y-axis there, vertical distance. So v squared is equal to 2 times 9,8 times 70. Then, like I did previously, you square root here so that do I need to square it? No, let's leave it like that. Actually, let me leave it like that. That is my v squared. Are you with me? Now, guess what? I'm able to come to this formula for EK, bring it in now, which says EK is equal to half times m times v squared, this formula. Remember, it's dot here, it's dot. So, which is equal to half times, what is the mass of this object? 0,15 times the v squared is this. That's why I didn't need to square it now, which is 2 times 9,8 times 70. I just take this part and substitute it there for v squared. And then I find the answer. It will give me what? That is another way, not simpler, but another option that you could have used if you wanted to go through that route. So it will be 1/2 times 0,15 times 2 times 9,8 times 70, which is equal to what? 102,9. Look at it, it's the same. 102,9 joules. 102.9 joules. Are you guys seeing? Those are 2 different ways you could have approached it, but the answer was going to be the same. That is that. I think we're done with question number 3. All right. Let's look at question. So that was it. Question 3, 7 marks. Question 4. This section is on what? Work, power, and efficiency. Quick things now. 4.1 says the parallel weight component to a plane is 215 newtons. The plane is at an angle of 17 degrees to the horizontal, and the object is moved 2,8 meters down the plane in 16 seconds. Ignore the frictional force. Very good. They want us to ignore that, so it simplifies things. Calculate the following, blah 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 blah. But we need to sketch this first. It says the parallel weight component of a plane, and this is a plane with an angle. So what you do, picture you've got a plane like this. There is the plane at an angle, and guess what? They told you that angle. They say it is what? 17 degrees. Okay, and then they're saying a plane at an angle of that, and the object is moved 2,8 meters. Will do that. The parallel weight component, that's what I'm interested in. Now, whenever you are dealing with this, there is an object here. Let's say it's starting here. That particular object, you need to know what is acting on that object. The first things first, that object has a normal, which is at 90 degrees to the plane. So you make like 90 degrees. That's your normal, which is, as I say, is 90 degrees like that, but you don't have to include that. It must actually start from the center. So this is your normal. But now, if you check my previous lessons, you need to know how to resolve this, because if you look at it opposite the normal, as I say, they meet at the center. Just directly opposite is the component of what? Gravity. This is weight that is perpendicular. So we usually call that the perpendicular weight. If you go to the formulas, it's there. They give you that perpendicular component of the weight. I think it's here. Those are the two. Look at this. They give you this Fs and Fc. F for sine, F for cos, but this is F parallel, this is F perpendicular. So the F perpendicular there is W cos theta. So if I come here, since they used F, I'll also say here, it's either you are calling it FC, but I like to call it F perpendicular, which is W cos theta, but theta there is 17. Alright, then we have got the weight parallel to the plane. See that one? Similarly, they called it the Fs, which is, I call it the F parallel, which is W sine 17 degrees. Are you getting that? Now the question goes and say, the parallel weight component to the plane is that. Meaning, this parallel weight component is that. So meaning already there is a statement there. What is the parallel weight component? Which is F parallel, which is equal to 215. That's what they're saying. Now 4.1.1, calculate the following: the mass of the object. Very good. Now mass of the object, you mustn't struggle. Look, we've got two formulas. F parallel, they gave us that, but we've got our own F parallel with a formula, which is W sine 17. Right, and you know what is W. You come back to this formula sheet. You know what is W. That W is weight is mass times gravity. Weight is mg. That's the small w. Mg, mass times gravity. So you come here and substitute to say F parallel is equal to mass times gravity sine 17. But we know what is F parallel. They told us it's 215. So you write 215 is equal to mass times gravity 9,8 sine 17. And what are we interested in? They want the mass of the object. So divide by what you don't want. 9,8 sine 17. Left hand side, right hand side. 9,8 sine 17, so that you can now find what? The mass of the object. Okay, so you will have now to say use a calculator there, and then so that you can be able to calculate that. Say 215 over 9,8 times sine 17. Okay, so it's 75,037. 3 decimal places, 75,037. So it's 75,037 is equal to m. So what is that? That is the mass of the object. That's what they're saying. So you're going to say, therefore, mass of object is equal to 75,037 what? Kilograms. Don't forget the units. That's wrong for me to leave it like that. It must be in kilograms because there is always the unit after the answer. Now 4.1.2 work done. 4.1.2 work done. Work done. Now what do you mean by work done? Work, if I go to the formulas, see, it's very intensive on formula. Work, this is the formula for work. Work is force times distance. That was weight is mass times gravity, but work is force times distance traveled. So you come here and say, for work here is equal to force times distance, which is equal to, now they say the work done. They are saying the parallel weight component, the plane is at an angle of what? 17 degrees to the horizontal, and the object is moved 2,8 meters down the slope in 16 seconds. Meaning, let's say it starts here, it will move down, and then let's say it stopped there. So they're saying that distance that was moved is what? Is 2,8 meters. It was going down. Are you seeing that? So that distance So that's why now we come to say work done is force. What was the force? They told us the force was 215, which in the parallel, times the distance moved is what? They told us even the distance is 2.8 meters. That's it. Work done, you multiply those two, and then you're good to go. 215 times 2.8. And what's the answer? 602. So remember now, work is measured in what? Joules. So 602 joules. That's the work done. That was that. Okay. Moving on to the next. Nothing else. This was the end, but let's move on to the next question. The next question here, 4.2, still in question 4. They're saying the graph below represents a block lifted from the ground by means of a chain to the top of a building which is 60 meters high. So I think again refer to the previous lessons. I've done quite a lot of work here. It says the graph below represents a block lifted from the ground by means of a chain to the top of a building. So we always say picture a scenario where you have a building like this. Alright, so this is your building, and in this building you want to lift something down here like a block from the ground. Alright, so this is what you want to lift, but what are you using? You are using a chain. See this? That's what they are saying. Maybe there is a crane here, some ways of bringing this, I don't know, whatever, but let's say there is a crane or whatever, just that it's a chain. So this block is going up. That's the block. So here they are saying the graph below, this is the graph that represents that. And then whenever you're talking about this, you need to actually understand what this graph means. Now, this graph has got a horizontal line, as you can see. Now you must be able to interpret this line. Let me make it thicker. You must know what is this line. What does it mean? This is the weight of the block. Always remember that. If they ask you what is the weight of the block, the weight of block is horizontal. See, it's not changing. Is equal to 3,000 Newton. And then what about the weight of chain? Because the chain also has a weight. Now initially the weight of chain, you start at 0, you see is 4,500, but remember there is the weight of the block. So you're going to say 4,500 minus 3,000, which is the weight of the block. Then you're going to get what? 1,500 newtons. That is the weight of this chain at the beginning. Just know that. But remember, as you are pulling this chain, the moment the block is somewhere here now, there is no more chain left. That's why the weight of the chain now is at 0. You see, it's in a way is at 0, but only what is left is the weight of the block. The block is still weighing 3,000. So let's look at the calculations though. Calculate the following. Number 1, calculate the weight of the chain above the ground. You see, that's what they wanted. There it is. You just use that calculation. Weight of chain is 4,500 minus 3,000 is 1,500. They just give 1 mark. That's why it doesn't have lots of marks. 4.2.2. Calculate the total work done pulling the block by the chain. You must understand what is the formula for work done. Okay. Now I'm forced to erase these in a way. Yeah, let me erase this because we did calculate that. We said this one is what? 1,500 newtons. Now, when they say calculate the total work done, remember the formula for work done, we said it is what? Force times distance. So if I can write this formula for you here to remind you, to say formula for work is F times S, force times distance. Now if you look at force times distance, you can see that this is the area underneath this graph. So in a way, we want to find the area of these two shapes. We are going to find the area of this triangle. So it's area under this graph. That's all that we're doing. So you must know the area under the force distance graph is the work done. So we want that, and I also want the area here. So it's not difficult. It's just the area of these two substances. Now the first one, it's easy to find. You're going to say area. Let me use the red here. I'm going to say area, which is area of this triangle, is equal to half times base times height. Now, which is half times the base is this distance here, from here to here. That's the base, which is 60 meters. You can just say that. So half times 60 times height. The height is from here to here. 3,000 to 4,500 is 1,500 distance. That's the height. So you say 1,500. That's the area there. What about the area here? The area here is equal to, is a rectangle, length times breadth, which is the length is 60 times the breadth is from 0 to the top, or the height, which is 3,000. That's it. Now the question is, when they say calculate the total work done, you are adding these two. That's all that you are adding. You are adding those two. So you are going to say in here, total work done. Let me just do here. You guys can see, I'm not going to write this. Total work done. Total. Let me use a different, show that is not about this one. 3,000. So I will say total work done is equal to, you just add those two. So I'm just going to use a calculator here. I'm not going to waste time, which is 1/2 times what? 60 times what? 1,500 plus, you can put that in brackets so that you are comfortable, you're not making errors. Okay, so you put that in bracket, like this, and then you have plus, again put in bracket, 60 times 3,000, the close there, equal to, and then you've got that, which is what? 225,000 joules. 225,000 energy work done. Energy is always in joules, or you divide by 1,000, you can say 225 kilojoules. If you divide by 1,000, these three will fall, so it will be 225 kilojoules. It's up to you how you want to live, but the first answer is still valid. That is that. All right, now 4.2.3, calculate the power required to lift the block at an instant when it is 30 meters above the ground with a velocity of that. So they want us now to calculate what? The power required at an instant to lift the block. Now when you come to power, I think there is a formula for power there. Power is work done over time taken. Now let's check if they gave us time, but I don't remember dealing with time here. Only they gave us, what did they give us? Let's see now. They gave us the distance and displacement in a way, and the velocity. I think there is a formula that links that in here, where power is linked with that. There it is. So they wanted you to use this formula. Power is force times velocity. That's why they gave you the velocity. So power is force times velocity. So I can write that formula to say P is equal to F. They put an E, but let's just write it like this: force times velocity. All right, which is equal to, the question is, do we know the force? Yes. If I say this, they gave us a hint, when it is 30 meters above. Now 30 meters is half of this. Remember, this is 60 meters, so 30 meters is like, you have half of that. When you go to that end, you find out what is that distance there. What is that distance? And that distance will be 3,000 plus half, because this is half of 1,500. So if you say 1,500, you divide by 2, what are you going to get? You're going to get 750. So in a way, that distance there is 750. But you can do a formula simple and do it like this, to say force, power is force times velocity, which you are saying 3,000, that we said here, 3,000 plus 1,500 over 2, that's 750. You see, that is the force, that's the total force, times the velocity. They told us it's 8, and then you get the answer. You understand? So that's what they wanted at this stage, to say 3,000 plus 1500, which is that 750 in a way. I'm just showing you the actual working if you want, and then times 8. And then what you get? You get 30,000. So power is 30,000. Now we're dealing with power. What are the units for power? It's up to you. Now force times velocity, you can remind yourself, force is in newtons, velocity is in meters per second. Even if you use that, they will mark it correct to say 30,000 newton meters per second, but that's not the unit of power. The simple unit of power is in watt. Remember, it's in watts. Power is in watts. You can divide by 1,000, which is 30 kilowatts. It's up to you, but that was the answer there. All right, guys, we are now going to question number 5. I think if you are satisfied with this, I hope it does make sense. Let's move on to the next. But if you've got questions, drop me a question on our YouTube app. I mean on that YouTube channel, and then I'll be able to see them. I might respond also on that. Question number 5. Let's move on. I think because of time, this will be the last one. I'll do this last question, and then I'll do the third video. So let's look at this first one. 5.1. Name 3 advantages of gear drives. Remember, gear drives. What are we dealing with here? When we are dealing with gear drives, we are saying these are, this is not right. I'm trying to draw a gear drive. So it's like a cycle with teeth. Remember, gears. And then you've got another cycle with teeth. These are gear drives. Now you've got the center, you've got the center. So we're talking about this when this one is rotating this way, this one is rotating this way. Those are like gear drives. So what are the advantages of gear drives? Number 1, the most common thing, because of the meshing of the teeth, is that there is no slip in gear drives. Number 2, they are very strong. Because there is no slip, they can transmit greater power. Okay, guys, how many marks? They wanted what? 3. They don't have slip. That's the first one. Because of that, they can transmit greater power. And then also, what you can do also is, because they don't have slip, slipping, actually the most important answer that I usually use is they don't have slip. Now because of that, number 1, greater power. Number 2, they've got a longer lifespan, because slip actually reduces the lifespan of belts. There is a longer lifespan, you see now. So these 3 actually are sufficient, And then another thing that you can do is they can travel at high speeds. Travel at a high speeds, Now also gear drives, think of a watch. In a watch, you have got the minute hand, the hour hand, and the second hand. So you can actually parts, because of gear drives, parts can move at different speeds. As I said, think of a watch. Different speeds. The hour hand is moving at a different speed than the minute hand, than the second hand. So different parts can move at a different speed. So anything, guys, that was sufficient for you, it's fine. Let's move on to the next one. The next one, what they say, name 2 methods of reducing belt slip. You see, belt, they do slip in belt drives. Now, how do you reduce slip? Now, in belt drives, let's say you've got a pulley, and you've got another pulley, and you have your belt moving like this. This is your belt. Now, when they slip is because this can be slack. Find that this is slack, so that when this part starts rotating, the belt comes off. Now, how can you reduce that? Number 1, you can stretch these pulleys apart. You can bring them apart so that this belt can be tense, so that instead of it like that, it can be actually so tight like this. You understand? It won't move out. So number 1, by tensioning the belt. That's the right word. By tensioning the belt. Tension the belt. How do you tension the belt? You can tension the belt by moving pulleys apart. Moving pulleys, because it's slack, apart. Or sometimes we tension the belt by introducing an idler, but let's not go detailed. Let not be detailed. The simple answer there, tension the belt. You don't have to say by. They didn't want the reason. You can just say by tensioning the belt. Number 2, how can you reduce the belt slip in belt drives? You can increase this contact. Let me show you here. There is this angle of contact between the pulley and the belt, where the pulley is in contact with the belt. If you increase it straight one, see that? Like this, there is no slip. So secondly, you can increase contact angle, or angle of contact angle between what? Between pulley and belt. But the key word there, increase angle of contact. The other one, you can also adjust the what can you do? You can actually adjust the deal with, I think, is the what is that one? The coefficient of friction, the mu. You can actually in a way consider the belt with a high mu, high coefficient of friction. Well, it's 2 marks, but next time if you want to edit, consider a belt with high coefficient of friction. There is also speed ratio. You can adjust the speed ratio of the belt. Use the belt with a higher speed ratio. So these are the 2 that I'm most confident on. The first one, increase the angle of contact, and then also move the belt apart for tensioning. All right. 5.3 says make a neat labeled line sketch of a differential wheel and axle lifting machine. 4 marks. They usually don't ask this question, but I remember drawing it also in one of my sketches to say, take note, a differential wheel and axle. It mustn't also scare you. You just draw something like this. You've got this one, the first one, then you reduce it further. You get the second one. You know what? It's simple. It's more of cram it out. Then you reduce it further. That. Then you're done. That's a differential wheel and axle. See what I just did? The only thing they need now is the labeling and other stuff. Now, let's do the labeling of that. Look at that. You start with this one to say this distance here. What is it? And then after that, this distance here. Let me use a different one. This distance here. That one. That's the main part. Once you draw that, the only thing is about the distance, and then also this distance here. Was it difficult? No. And then when you have done that, just a little bit that you need to do. Nothing much, as I say, nothing much. You just need to introduce the pulley now. Where is it? Your pulley will come from here. So this is what you do. You draw, there is a pulley here, and there is a pulley here. They say the line diagram. I didn't want to use that one. Let me use a white one. There is a pulley here that you're going to introduce, and here. So you put a pulley in here which will link to your what? This will link to your load. So you do that. And then this, then you can now, they say it line diagram, so let me be sensitive to use a line. This becomes your load. See that? So that is a load. This is your pulley. In this pulley there is a snatch block. So that's your pulley with the snatch block, but let's do that. Then this is the load. Now what's next? Just a small few adjustments. What you simply do here, you continue these lines like this. Then this one, make it half. Then also here you continue these lines like this. Then this one, make it half. And then here also you start there though. Start long one. You make it long. Now remember, where there is a load, there must be what? An effort. So you make it long, and then you just also do this again. Do another one, and then the other one, make it like that. So here you just do to say they ended there and they ended there. We are done. So this becomes your effort. Now you're asking me, but you're saying you must label. this is your smaller diameter D1, this is your bigger diameter D2, and the big diameter, which is your D. That is the differential wheel and axle. Okay, so anything, I don't think it was difficult. You guys must get used to this. Okay, just practice it. You saw how I started and everything. Just work backwards, do reverse engineering and see what I did. It will actually work for you. Now 5.4, the Western pulley system has a big diameter of 300 millimeters. Already it means be careful. They are dealing with millimeters. Be careful. You don't work with millimeters, but you work with meters. But anyway, you need to know the conversion. And a small diameter of 150 millimeters, again, be careful. An effort of 166 newtons is required to lift a mass of 54,082 kg. So kg is good, newton is good, but the problem, that is not right. But obviously, I need to convert that to what? Meters. You divide by 1,000. Remember, 1 meter is 1,000 millimeters. So if they give me the 300 millimeters here, if I go to the meter, it must be small. So the meter is small, is bigger than the millimeter. So I need a small number here. In other ways, I'll say x, you cross multiply. X times 1,000, it's 1,000 x is equal to 1 times 300 is 300. So the simple thing is how you go about to say, why must I divide? That's how you work on it if you want to do it mathematically. But that was not necessary going through that stage. But you need to divide. You take a calculator, you divide by that. But let's go to the questions first. Calculate the following. 5.4.1, the displacement ratio, 2 marks. The displacement ratio. Let's go to the calculator. Now, look at this. The Western pulley system has a big diameter and small diameter. 2 diameters. You have a D, or it can be D1 and a D and a small d. There are 2 things here. That D, or you have got a D1 and a D2, where D1 is bigger than D2. Are you with me? Let me just see what I did. Is it right? Yes. D1, D2. Even here on a differential wheel and axle, D1 is small, D2 is big. You see that? But there is that D. So now let's go to the formulas here. Just rely on your formula sheet. Look at this. Where they talk about the differential wheel and axle, there it is. There it is. There it is. We are here. You can use this one, these 2 formulas. You see? D and D2. And at the same time, you have got this one and this one. Both formulas were going to work. So if I use this one part here to say, what was the question saying? Displacement ratio. So you see here on the formula, dr for displacement ratio, so is 2d over d1 minus d2, or 2d over d minus d. So I can use any of these to say here, this first one, 5.1, displacement ratio, dr, is equal to 2d over what? It was d minus d. Let's check that. Here it's there, 2d over d minus d. Now this one, actually I can't use this one because there is for the differential wheel and axle, where there was a d, a d1 and a d2. Remember, the differential wheel and axle means 3 diameters, but still it was gonna work if they gave me those 3. But since they gave me 2 diameters, a d and a d, I cannot now use the other formula. So I've got only this bigger diameter d and the smaller diameter that. So which means, don't forget, I said you need to convert. So you take your calculator and you say, okay, I need to convert that 300. So it's 300 divided by 1,000, so that you know what you write. They don't give much for that. It's 0.3. Even the 150 of the other one, you divide by 1,000. It's what? It's 0.15. You see that? So the answer here will become equal to 2. Now the big D is so that it was 0.3 after dividing, over the big D, which is 0.3, minus the small d, which is 0.15. Remember, the 0.3 is that 300, 0.15 is that 150. Okay, let's look at the answer there. What does it give me? it gives me 2 bracket 0,3 close the bracket over 0,3 minus 0,15, and then it gives me what, 4. So the answer here, the displacement ratio here is 4. No units, leave out the units. That's the first one. 5.4.2, the mechanical advantage, MA. Use a different pen. Let me look for MA now. What is the mechanical advantage? Go to your formulas. Always rely on your formulas. Look at it. Mechanical advantage is load over effort, L over E. So you come here to say MA is L over E, which is equal to, now what is the load? They told you a Weston blah blah blah, an effort of 166. They gave you only E. But what about the load? Is required to lift a mass. There is the load there, hidden there. Is required to lift a mass of what? 54,082. So now there is a bit of working you need to do. You need to come here to say M is equal to 54,082. Now to calculate the load is same as weight, which is W, which is mass times gravity. You understand? You multiply by gravity to convert this mass into weight, which is becoming your what? Your load. Remember, if this something is hanging down, we are saying the first working down is weight, which is M times G. Remember that weight. That's why we multiply the load as that, which is 54,082 times 9,8. That is our L. So here I can write now and say mechanical advantage is 54,082 times 9,8, which is my load, over the effort is 166. Then I can get the answer now. And then it will give me here 54,082 times 9,8. Are you with me? Over what? 166. Mechanical advantage, again no units, 3,1927, which is 3,193 to decimal place. 3,193. Are you with me? So that is that. I've got what? Mechanical advantage and displacement ratio. Now the next question, these questions usually are common when they ask them like this. The efficiency, the flow. Efficiency, which is that like a you know, that thing like a U, you know, not like a U, like an N like this, you know, it's like an N. That's efficiency. Don't know how they write that sign, but it's your N which has got that efficiency. So you come here on the formula again, look not far but look this direction. There is that formula for efficiency. So efficiency is what? N is output over input times 100. That's the efficiency. Is there any other formula from what we have on efficiency beside input and output? It must be, because I want something to deal with what we have and in terms of the information that they've given us. So there's nothing here. Okay, I don't see any formula here, but it was important if they gave us that formula here. Efficiency, let me check, it must be there. I remember there. Sorry about that, I'm looking wrong. I was actually supposed to look just here. There is the formula for efficiency. See, N, there is that N. Let's take it from here. N is MA over DR times 100. You see, M is mechanical advantage over displacement ratio times 100. So let's write that for me. So what is your M? Efficiency, you write that efficiency is equal to MA over DR times 100, and efficiency is as a percent. So what is MA? There is 3, what? 193 over 4, that is our DR times 100, and then it's a percentage. Okay, that's what they wanted there, which is your efficiency. And then Obviously, if I apply now my calculator here, it will be efficiency is 3,193 over 4, multiply that by 100%. The efficiency is not above 100 in this case, 79.83. 79.83. Can't have it above 100. 79.83 in 2 decimal places. That's the efficiency of this particular Western Pulley system, which is good, not bad. Now we are done there. We are looking at question 5.5. all right, it's 2 marks. The last question here, I want to work on to the bottom. It says the absolute pressure inside the car tire is that. What should the reading be? What should the reading on the tire pressure gauge be when checking the pressure in the tire? Let's repeat again. The absolute pressure, that is P ups. The absolute pressure inside the tire is that, and then the reading on the pressure gauge, the gauge pressure. What should the reading on the pressure on the tire pressure gauge be when checking the pressure in the tire? There is a formula again for that, guys. You just need to be comfortable with these formulas. There is one. There it is. The absolute pressure is equal to atmospheric pressure and the gauge pressure. So PAPS is equal to PATM and plus PMET, the gauge pressure. So let's write that formula and say PABS is equal to PATM plus PMET. So what are we given? The absolute pressure inside the tire. We are given this information here. We are given that. I want to use a different. So we got that, and we have that. So we are looking for this guy. So what is the absolute pressure? The absolute pressure in this case they gave us is 235,56. Now pay attention here, careful. They are saying kPa. I will maintain that so that I don't make a mistake. Otherwise, you're supposed to convert this into pascals. But we want to see if ever kPa is being maintained, then we can work with that kilopascals. But in right way, you are supposed to multiply by 1,000 so that you remove that kilo. But the atmospheric pressure, where do you find it? Go to the beginning. You will find the atmospheric pressure. There it is. Not this one, but the second one. There it is, atmospheric pressure. And you see they gave it as 101,3 kPa. They maintained the units. So 101,3. So I'm going to take it here and say, since they maintained the units, I don't have to worry, and write it as PATM is 101,3 kPa plus PMET, which is the gauge pressure. They want the gauge pressure now. So the question is, what should the reading on the tire pressure gauge be? So what you do is, you can see that you want PMET. Take this to join the other one. So you've got 235,56 kilopascals minus 101,3 kilopascals, units are maintained, is equal to PMET, the gauge pressure. Then after that, let's get the answer. What is it? Just subtract, guys. Nothing much. Nothing complicates here. It's just simple. 235,56 minus 101,3. If you did it well, what am I getting? I'm getting 134,26. 134,26. You know the units already. kPa is equal to what? PMET. Don't confuse yourself there. Then you can conclude and say, therefore, pressure gauge or gauge pressure is equal to 134,26 kilopascals. I'm actually lazy to say pressure gauge reading, because what should the reading, pressure gauge reading, I was feeling lazy to write that word, reading, is equal to that. So guys, it gives you what? the absolute pressure inside the tire. Okay, we're done with that question. Are we done? Let me see. It seems there is more of that question. No, because this is now question 6. So that is, oh, there it is. It was 17 marks. So it went to the next page. This question was 17. You see, they just cannot just put 17 there. This was for the previous question. So that is that, guys. Now you need to tune in for the next section where I do question 6, friction, question 7, heat, question 8, particle structure of matter, and question 9, electricity. It's not much left, but you need to tune in. As I said, it is important for you guys to subscribe. If you're not subscribed, you will lose out on some whatever new things I'm bringing. So it's very important for you to subscribe. Ensure that the notification bell is turned on. You will be notified every time there are new videos. If it happens that this video is not available in real time, I'm sorry. I first made it available to premium members. Then if you are watching it and you are just an ordinary member, just know that I've released it now for everybody. But I always encourage you, if you want to support us, ensure that then you join the premium members. It's just a small contribution every month, but it helps us to run this channel. Remember, this channel is for you in mind. You might be able to afford paying a couple of rands, maybe around 80 something rand, but someone is struggling to even get data to watch this. So support that person by contributing to this channel. I hope this makes sense to you, and I hope you to pass and you get that distinction that you're looking for. If you want to excel, you need to reach out. That's why this channel is reaching out, is proof of passion, and it is for you whom I consider being the underdog in this subject, but you want to excel. Because I was once in your chair, I was once in your shoes. I struggled before very much with maths, especially mathematics. Science I understand, because when your maths is intact, science just follows. So I struggled a lot with maths. Hence you see primarily this video or this YouTube channel 24 minute is for maths, but science is the result of maths. It's just something that comes in natural to you after that. So check again more on videos on these, especially mathematics, and then remember, this channel has got you in mind. Leave me a comment, drop me a comment, share this channel with your friends and colleagues. We've come to the end of our lesson. Join me again in the last section. Thank you.